And hello everyone, welcome back to your Lua tutorial. So here we have our terminal. I decided to use the integrated terminal for once, so you can just go to terminal and say new terminal. And yeah, there we go. Then we have our integrated terminal here, and here's our Lua code. We should actually remove that because we'll be getting to that. Cool. So today we'll be talking about functions. So a function you can think of in a sense as a block of code that you can basically copy and paste without having massive repercussions. So imagine you have like a block of code. So let's say we print out print you are 5 years old. And then we go and say, okay, now here we can put a few new things. You will be, and here we can say 7 years old in 2 years. All right, and in here we can say you, and we can go were 4 years old last year. Cool, now we have that. So if we have that, we can actually just print that. So we can just say Lua and then run it here. So why isn't it in this folder location? Let me just quickly go there. I believe if I just maybe drag and drop this in here, it would probably, no, it will not autocomplete it for me. Okay, then you go to documents, trash, Lua, and here we can execute our Lua file. All right. So here it says you are 5 years old, you will be 7 years old in 2 years, and you will be 4 years old, or you were 4 years old last year. Perfect. But now let's say here is 300 lines of code for something else. Let's say it's a game, and this is what we'll print out. And now let's say a year has passed or something like that, and then you have to paste it again. But now here you have to go, okay, 5, that should be 6. You will be 7 years old. Okay, so that would be 8 now. Oops, so you said 8, and you were 4, but now it was 5. And in here you have like another 100 lines. Whoops. And now you have to do it again. And you have to paste the same 3 lines of code over and over again, which kind of adds up. And this is just a very basic example. There are much more complex examples than this, but for right now, I believe this is perfect because it's just such a basic and small example. So here we have it, and now it's like, okay, now we have to update it again. Well, it's not really the updating that's bothering us, it's more the fact that we have to copy and paste these 3 lines of code, because sometimes it will be 15, 20, or even more lines of code that we have to copy and paste every time. So if you do that, bugs can happen, and probably will, and it's very bad practice. So there's a way around this. I'm going to keep this one at the top, and that is functions. So we can create a function by just saying function. And here we can say, for example, display age. And here we go. So this is a function. And in this function, we can cut this code and we can put it inside of this function here. And you can also make this function local if you want. So this thing with functions is it's basically the same with everywhere, just like with variables. So if it's a local function, it can only be used inside of this file. If it's a global function or an _g function, which is the same as a global function, then it can be accessed anywhere. But right now, we're just going to keep it local. Now this function is special in a sense that we can just say display age. If we do that and we run it here, as you can see, it displays the code for us. So you might be thinking, okay, but that doesn't really help us much because we're actually using more lines of code. But the difference is we can copy and paste this and have it print out multiple times, as you can see here. So instead of this being 3 times 1, 2, 3, 4, 5, so instead of this being 3 times 5, this is just, okay, we have this and we can have 5 of these. So it saves a lot of lines, and in the long run, this will actually clean up the code and make it easier to understand as well. Because whenever you need to know something, just go back and reference this function here. So basically, a function is just a variable in a sense that keeps a piece of code and executes it as soon as it is called. So that is what a function basically is. Now let's actually improve our code, because in the previous example we actually changed the age. So here we can actually give it a value, and let's say age. And this value age here is called a parameter. You can use this parameter to update your function here. So I can say, okay, you are, and it's 5, but this time we can just say dot 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 dot, and we could push age into this. And now we have our age. There's a variable here. Same here, we can just remove the 7 and add a dot 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 dot, and here we can say age plus 2. And in here with 4, we can say, okay, dot 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 dot, and here we can say age minus 1. Let's try and do it now. So display age, and here we can say, okay, this age should be 22. Let's try it. You're 22 years old. You'll be 24 years old in 2 years. You were 21 years old last year. That's perfect, because now every time we want to do this again, but with something else, so let's start with, let's say 7, or yeah, let's start with 5. And then let's do one for maybe 13, and then one for 18, and then one for 25. Oops, that's 15 there. Now if we save and run this, we get one for each one. So you're 5 years old will be 7, we're 4. 13 will be 15, 12, 18, 20, 17. So this is a way to just clean up your code a lot, because instead of copy and pasting this and then having to change that manually, you can change it in here. But now you might be thinking, okay, but what if I just don't want to actually add an age in here? I just want to keep it clean unless I specifically want to change it later on. Well, to do that, you can create this parameter right there, and in here you can say age is equal to age, and then let's say 5. So if there is no value passed into age, it will default to 5. So if we go here, and I'm just going to add an extra print here, just to give us a clean line at the end. As you see, you are 5 years old, so it defaults to 5. So if you don't want to add anything here, you can just say, okay, take this and make it equal to itself. But if itself is not really a truthy value, if it's empty, if it's nil, then make it 5. So it's basically saying age is equal to age, and if age is nothing, it's nil or 5. And since 5 is truthy but nil is not truthy, it will choose 5. Unless age actually has something. And just make sure that this here is first. If you swap the two, then it will always be 5. So if we go like this, 5 and then age, then if you go here, it will always be 5. So just make sure that age is first. So that's how you also add default parameters here. So now that we know the basics of it, I think it's about time we can continue to something a bit more intense. So I'm going to create another local function, and this function will be called sum. Sum will take in a number, so num1 and num2. And what these names are, they don't really matter. You can call them whatever you want. Anyhow, they can say return num1 plus num2. Return is a special keyword in Lua, or actually in most programming languages. What it basically says is, okay, return this, put this inside of a variable, because if we didn't have to return, so if we go here and say just local x is equal to sum, and here we can say 2 and 3, so that should be 5, because 2 plus 3 is 5. So we can take in multiple arguments, and we can also add in stuff. And if we say print x, then if we go here, we get 5. But as soon as we remove this return, then it will just kind of say, hey, I don't know what's going on. Even if we add a variable here, so let's say let x is equal, sorry, my JavaScript is coming in here, local x is equal to num1 plus num2, we'll get nil. And I probably shouldn't have made that X. That probably confused you. Let's make that Y, and I'll talk about global and local scope right now. And you see we still get nil because this isn't being returned. We can even go and return Y. And once Y is returned, we will be getting the output we want because now this can actually store something in this. But take note, once return has been thrown, you cannot do anything after return. So if we say hello, then you'll actually see it gives us a red squiggly line because this, nothing is expected after that. So even if you try to run this, we'll get an error because it was expected that we would find end, but we found print. Take note, return ends the function. Once you put it there, you can't put anything after it. Now let's talk about a local and global scope whilst we're here. So we did talk a lot about local scope and global scope, and the difference between them is right here. So this local Y, it cannot be accessed outside of this function. So if I were to just comment, I'll just comment that out and say Y. So even though Y is here, and even if we were to actually do this whole sum thing, so even though Y is there, we'll still get nil because Y is a local scope. So we cannot access it outside of this function. But if we do this, or just go underscore g dot, then that will make it a global scope variable. You didn't have to put underscore g there, I'll just do it because it's considered good practice. Put it there and we can get 5, because now this is a global scope. This can be accessed from anywhere. So this is why we have the local and global scope thing. So we can't access anything inside of other file or function unless we want to. So keep everything local scope as far as you possibly could, so that this won't happen where you can access what's inside of here, outside here. But take note, you can access what is outside of the function, inside of the function. So if I were to go here and say local z is equal to 10, and I were to go here and just print out sum, and let's go chat free again, but this time we're not going to use this parameter right here. And I would just say y is equal to 1 plus z, then that would actually be a valid function. Because z is outside this function, so this function can access it. But whatever's inside of this function can't be accessed outside of the function. If you get what I mean, because this here is like one big scoping. So this file itself is a scope. It might be getting a bit confusing, but if I show you, we get 12 because z is here. So even if this was global scope, it would still be accessible here, as you can see here. The only difference is that whatever is outside of this function can be accessed inside of the function, but what is inside the function cannot be accessed outside of it. So that is the meaning between local and global scope, and we'll get more into this as time goes on. There's more than one way to define a function. For example, we can create a local variable, call it maybe add 10, and this can be equal to a function, and this function, let's say, takes in a number, and here we can even return something or execute or whatnot. So I'm going to just say return 2 plus num, or actually it should be 10 because we're saying add 10 here. So 10 plus num. And here we can say print add 10, and then we can go 5, and that should add up to 15, as you can see there. So this is another way you can create a function. It's up to you how you prefer to do it. You can also get multiple values returned in a function. For example, we can take in a number and then outcome. So here I'm going to say the outcome, actually shouldn't take in outcome, my bad. I should just take a number. And we can just make this local scope. And here we can say that is equal to 10 plus number. And here we can say, we can give the outcome, right? And this will give us what we expect. But we can actually return something extra. So we can return, let's say, the number that was passed in, the number, and then the outcome as well. So now here, I'm just going to create a variable to put it in. I'm going to say local and stored and output is equal to add 10. And here I'm going to say 20, for example. Now here, instead of print, I can actually go here and say print out stored. And here we can add some extra strings to it. Had 10 added to it. And here I can just say output. Say this, and if we run this, whoops, and you can say 20 had 10 added to it, and we get 30. So we can return multiple values here by just separating the outputs by a comma, and then if we can store it by creating our variables like this. If you're not planning on using one of these, you can make this, let's say, an underscore, and that basically says we're not planning on using it. So it's just common convention to do that. And if we run it now, we don't even have to worry, that underscore does not need to be used. Next part, we're going to be talking about recursion. Recursion is basically when a function calls itself until it reaches the answer it wants. For example, here we can create a function, maybe let's say a counter, so local function counter, and this counter can take in a number, and then the number should end with end num. I'm going to give that an underscore. So it takes in a number and a number it wants to end with. Now I'm going to create a local variable called count, and this count will be equal to the number passed in plus 1. And then we can just return count for right now, and I'll continue with what it actually does in a second. Now here you can say print counter, and let's say 10 to 15. So we want to start with 10 and we want to end at 15. Run it, we get 11. So it's a normal function that just adds 1. Cool. Now here we can actually say if count is less than the end num, then we want to do something. So then, and here we can just say return, and we can call this function again in itself, counter, and we can pass in the number we want to count. So in this scenario, count, and then how much we want to count it up with, so end num. And now if we were to print that out, we get 15. So it counts it all the way until 15, and we can actually put a print statement here as well, so print, and we can just say count. Run that, and you can see we get 11, 12, 13, 14, 15. So what this basically did is we said, okay, create a local variable called count, and that's the number plus 1, right? Then we check, is this less than the number we want to end with? If it is, we're going to print count, and then we just print out the count, so the number it is, in this case it would be 11, as you can see there. And then we return this value, so we are calling it again. So it's going, okay, whoop. Now this number here is this value here, so this was 11 now. And they were saying, okay, 11 plus 1, that's 12. Is it less than 15? Yes, it is. Print it out. And it just continues like that until it finally reaches, let's say, 14. And it could, okay, increment 14 here, and that's 15. Okay, and then is 15 less than 15, which is right here, that's the end number, and it's going to no, it isn't, so it's going to skip this part and it's going to return the actual value. So that's a recursive function. It just calls itself over and over until it meets its condition. So next up we'll be talking about anonymous functions. So we'll yet again be creating a counter, but this time with an anonymous function instead. And this counter will be a little bit different. So here we can yet again create a count variable there, and we can just make it equal to 0. And this counter doesn't have to take in any value whatsoever. And we can just for right now return count. Now if we were to print out count here, then we get 0. And we try it again, we get 0 the whole time. Perfect. Now we want to, whenever we call this counter, we want to get that value. So, or whenever we call this function, we want to increment that 0. And that's where anonymous functions can come in handy. Anonymous functions are basically functions without a name. So this function here has the name counter. An anonymous function will not have a name. So here we can just say return, or actually we can just use the return that's already given to us. Okay, so here we can say, maybe just click there, return. And that return's actually already there. We can return a function, and this function doesn't need a name, so I'm just going to go there. It doesn't need anything to put into it, and we can say count is equal to count plus 1. So we're incrementing count, and then we return count. So basically, we are returning a function that will take this count right here, that 0, and add 1 to it, and then we'll return that value. So if we were to just go like this, and as you can see, we actually get a function here. We don't really want that function location, so we're going to say local, I'm just going to say local x is equal to counter. And this is a way to get around it, because remember, it's returning a function, and that function is anonymous, so it will just return this, the location. We don't want the location, we want this right here. And putting it inside of a variable is a way to get around that right there. And we can just call the x, because this is returning a function. So we're getting a function back and stored inside of x. So this x is this function right here. Now if we say execute that function, then it's going to take this count and it's going to return the count. That is why this x is also a function right now. Might be a little confusing, but if we go like that, we get 1. And now if we do this, we get a counter from 1 to 7. So that's pretty cool, because this x has just once initialized this count 0. That's what happened here. So it initialized it and it got returned this function. So now x itself is a function. And now we're calling the function that x is, so this one right here. And we're saying, okay, execute it. And then it already knows what count is because it stored it here and now it has a memory of it. And it's saying count is now equal to count plus 1. It becomes 1 and it returns 1. But count has stayed 1. So now when we call it again, count is 1 because we stored it. And then count plus 1, and then it goes back here. And now we have 2. And that is an anonymous function and all its glory. Alright, so I know it's becoming a little bit of a long video. So what I'm going to be doing is just give you one more thing to look at. So I'm going to create another function. And this function will be called sum once again. And here, let's just say x and y for right now. So x and y. And here you can say return x plus y. And in here, we can say print sum 10 and 5. And that will give us 15, right? 15. But sometimes you want to take an infinite amount of arguments. You don't know how many arguments should be passed in. And the way you can do that is you can say here dot dot dot. And this dot 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 basically becomes a table. And that table gives us what we want. So if I say, we can just actually, we're just going to, for right now, return 6 or something. And we're going to just print out that dot 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 we get returned. As you can see there, we get 10 and 5 because 10 and 5 have been passed in. So if we go here and add 9 and maybe 0 and 14, just save that and go here and run it again. As you can see, it just gets added to it. So it basically returns a form of a table, but not really quite a table, but it's relatively similar. So let's create a variable here and just call it sum. So local sum. I'm just going to call it sum, so it's not the same as the function name here. And it's going to be 0 once everything starts. And then I want to loop through this variable right there, or through that. We want to loop through that. And here we're going to use pairs. I'm just going to say pairs. Whoops. For and here it actually got completed. So pairs is a way to also loop through tables. So here we can, as it says, have a key, a value, and here we can pass in a table. But this, as I said before, is not quite a table, it's more of a string. As you can see here, we don't get returned a table, we get this, which is basically a string. It's just a bunch of numbers that has been added. So it's not really a table. So what we'll do is we'll just go like that. And that will convert it into a table, because we're putting it in table thingies right here. Now let's first print out what we get. So let's print out key, just so we can see what is key. We go 1 to 6. The key is the index. So this would be index 1, index 2, index 3, 4, 5. And then the value would be the value associated with that index. So here we can just run again. And as you can see, we get 10 to 4. And this 6 right here, you don't have to worry about it. It's actually just being printed out here. So that's 6. So we can actually just change that to print, just so we don't get confused again. Because for a second there, I wasn't sure what was going on. But yeah, if we run it, we get 1, 10, 2, 5, 3, 9, 4, 0, and 5, 14. Just as we put them in here. So index 1 is 10, index 2 is 5, index 3 is 9. And here's printed, and that's what we're printing out there. For a second there, I did get confused because I wasn't sure why there was an extra value there. Anyhow. And if we add more here, it will automatically allocate these there. So boom, as you can see there. Now we don't really want the key, so if you wanted to, you can even make this an underscore because we're not going to use the key. I'm just going to keep it as key because I don't really care. And here with sum, I'm just going to say sum is equal to sum plus value. So we're saying, okay, this, or the sums, not sums, is equal to sums plus value. So it's going to take the 0 and it's going to add the first value, that will make it 10. Then sums will be 10. So then 10 is equal to 10 plus, and then 5, so that will make it 15. And on the end of the day, if we print out sums, we'll get this. So it's just basically the sum of whatever in here. So if I say, whoops, 10, 5, and 10, that should give us 25, as you can see right there. So this is just to take in an infinite amount of arguments, as you can see here. And we can use this right here to transform it into a table. And we can use this for loop to loop through that table. And yeah, there we go. If you wanted, you could have used a normal for loop, so just for, and I becomes like, whoops, I becomes like, whoops, I just 1 to the length of, and then you just do that, whoops. And that would be perfectly fine. But this pairs here also gives you the key, so you can use that if you want to as well. So yeah, that is functions. I hope you all understood. If you had any questions, feel free to ask in the comment section below and I'll do my best to help out. Thank you for watching. I'll see you all again in the next Lua tutorial.